Okay, so today we're talking about statistical studies, the type of different studies that you can do. And apologize for this. This is going to be a lot of reading, but I'm probably just going to pause it and let you read through it, and then we'll answer the questions. So if we start here, do need to notice this over here. This is the main thing. This lesson discusses the three main types of statistical studies: observational studies, surveys, and experiments. And it defines each type, gives each, for example, and asks students to distinguish between them. So an observational study records the values of variables for members of a sample. There are several types of observational studies. Observational studies are designed to observe subjects as they are, without any manipulation by the researcher. And that's the main point within an observation, is you're not doing any type of manipulation. Now, a survey is a type of observational study that gathers data by asking people a number of questions. So it's just simply sitting back and recording what people respond, or how people respond to certain questions. And an experiment assigns subjects to treatments to see what effects the treatment has on the response. Okay, so there's your three different kinds, and you need to be able to understand what those are and be able to pick those out and create those. Okay, now one thing before I let you go back over here and read this is you need to think about these types of studies. Okay, we have experiments. Okay. These are experiments here. You also have observations, and inside of observations you have surveys. Because remember, you're not doing anything with a survey either. You're just making observations on how people answer questions. Now, observation is much bigger because you could do a survey inside of an observation and then see what's going on by making specific observations. But you're not going to manipulate. Okay? So, I'm going to go back over here, give you a second to read through this, and we're going to answer A, B, and C. Okay, so you could pick a random sample of people and ask them the question, do you like rock music, and record their answers. What kind of study is this, or what kind of statistical study are you looking for here? Well, that's going to be a survey, right? You're just asking a question and seeing how they respond to it. Now, B says you could pick a random sample of people and follow them for a period of time, noting their music purchases both in stores and online. Well, random, following them for a period of time, noting their music purchases, these are things that you're going to be observing. Okay. You can pick a random sample, let's see, you can pick a random sample of people, separate them into groups, and have each group listen to a different genre of music. You would collect data on the people who display an emotional response to the rock music. Okay, so this is where you would run into an experiment. Because you're looking at you've done something to the people, right? You've put them in a group to listen to a genre of music. So you're doing some type of manipulation in that. Okay? So hopefully you read through this and understand what a survey, observational study, or an experiment is. Now let's go to the next page. Okay. Here we have a chart. And it says it is easy to determine if a study is a survey A survey asks people to respond to questions, but surveys can be flawed in several ways. Questions may be confusing. For example, consider the following question. What kind of computer do you own? Circle one, a Mac or IBM PC. How do you answer that question if you do not own a computer? How do you answer that question if you own a different brand? A better question would be, do you own a computer? Circle one, yes or no. If you answer yes, what brand of computer is it? Okay, now consider the question. Do you like your school's cafeteria food? Rewrite the question in a better form. Keep in mind that not all students may use the school's cafeteria, and even if they do, there may be some foods that they like and some that they do not like. Okay, so this is how you would record this information up here in this chart. But now, what question are you going to pose so to be a good question? Remember, you can have a survey with a question, but is it a good question? Well, instead of me writing this out or typing it out, we're just going to scroll this down, I think. And it says, do you eat in the cafeteria? If yes, please indicate which items you like. Okay, so that works out well. Which items do you like? You could also include in that this list of items and say, rate them as like, do not like, or have never tried. So there's a bunch of different ways, and you need to think about the most accurate to the question that you're wanting to answer, and also get as much information as possible. Here we're just looking at the ones that you like, which we could do if you didn't indicate those, then you could say the ones that you don't like, but then you may not know if they've ever tried them. So you got to be careful as to how you answer those questions, or ask those questions actually. Question 4, or page 3, sorry, no, we got question 4. B, something else to consider with surveys is how survey participants are chosen. If the purpose of the survey is to learn about some population, ideally participants would be randomly selected from the population of interest. If people are not randomly selected, misleading conclusions from the survey data may be drawn. There are many famous examples of this. Perhaps the most famous case was in 1936 when the Literary Digest magazine predicted that Alf London would beat incumbent President Franklin Delano Roosevelt by 370 electoral votes to 161. Roosevelt won 523 to 8. Talk about electoral votes there. 10 million questionnaires were sent to prospective voters, selected from the magazine subscription list, automobile registration list, phone list, and club membership list. And over 2 million questionnaires were returned. So 10 million sent, 2 million returned. Surely such a large sample should represent the whole population. How could the Literary Digest prediction be so far off the mark? Okay, so what could have went wrong there? We could have said, okay, we could say that the sample was biased towards the wealthy, because in 1936, during the Great Depression, the wealthy were not representative of the whole population of voters. Another difficulty was that not everyone who received the survey chose to return it. That resulted in what is called voluntary response-based bias. Okay? So if they don't like what you're maybe questioning, they don't respond to it. And then maybe the ones that liked Franklin Delano Roosevelt. Okay? Page 4. Page 4 says an observational study, so we've gone from survey to now an observational study, records the value of variables for members of a sample, but does not attempt to influence the responses. For example, researchers investigated a link between the use of cell phones and brain cancer. There are two variables in this study. One is the extent of cell phone usage, and the second is whether a person has brain cancer. Both variables were measured for a group of people. This is an observational study. There was no attempt to influence people's cell phone usage to see if different levels of usage made any difference in whether or not a person developed brain cancer. Why would studying any relationship between asbestos exposure and lung cancer be an observational study and not an experiment? Well, you're not influencing the study. That's how. All you're doing is making the observation about the exposure and lung cancer. You're not making people be exposed to asbestos, okay? And you're not giving people lung cancer. You're not doing any of those type of things. You're not influencing the study, okay? Now, in the next one, it says, in an observational study, just as in surveys, the people or objects to be observed would ideally be selected at random from the population of interest. This would eliminate bias and make it possible to generalize from a sample to a population. For example, to determine if the potato chips made in a factory contain the desired amount of salt, a sample of chips would be selected randomly so that the sample can be considered to be representative of the population of chips. Discuss how a random sample of 100 chips might be selected from a conveyor belt of chips. So you've got this conveyor belt coming down. You're checking to see how salty they are, or if they meet the desired saltiness. How would you choose those 100 chips? Well, you have to talk about the certain intervals throughout the day. Maybe you take 25 chips between a certain period, or you just do say, let's do 10 chips every hour, okay? And say the factory works at least 10 hours a day. There you go. There's 10 chips every hour, and that would give you a good sample of the population. Because what happens if somebody that worked that morning shift has salted more, they put more salt in there, okay? And then the evening ones, they didn't. So you need to get a good sample between the whole day. Okay? Suppose that an observational study establishes a link between asbestos exposure and lung cancer. Based on that finding, can we conclude that asbestos exposure causes lung cancer? No, we cannot. It is impossible. It is possible there are other variables that have not been examined, okay? Such as whether or not the subject smokes cigarettes, okay? So, just because we see a link doesn't mean a cause and effect scenario. Because of the asbestos exposure, they now have lung cancer. Well, maybe not. Maybe they're a smoker. Maybe they have a genetic predisposal to having cancers. Okay, so you don't really know that. You can't make that assumption. D says write or say to your neighbor the importance about observational studies. Okay, so we've already talked about these. The cause and effect is a very important issue. The main disadvantage in an observational study is that the cause and effects conclusion cannot be drawn from any relationship observed in such a study. Okay. And you need to limit the bias and have a random selection would be another one. We'll let you read that on page 6 there. Okay, it says right here, is the following study, or the following an observational study or an experiment? Why? If it is an experiment, identify the treatment variables and response variable. If it is an observational study, identify the population of It says a study was done to answer the question, what is the effect of different durations of light and dark on the growth of radish seedlings? 3 similar growth chambers, plastic bags, were created in which 30 seeds randomly chosen from a package were placed in each chamber. One chamber was randomly selected and placed in 24 hours of light and another for 12 hours of light and 12 hours of darkness, and a third for 24 hours of darkness. After 3 days, researchers measured and recorded the lengths of radish seedlings for the germinated seeds. Okay, so let's see. It is an experiment. Okay, the treatment is the variable light exposure, whether they're in darkness for 24 hours, light for 24 hours, or light and dark 12 hours each. So those are your treatment. That's the things that you're putting in the experiment. That's what you are manipulating in the experiment. So that's the treatment. Now, what are the response variables? Well, it's going to be the growth, how they have grown. Okay, whether one grew more in light or in darkness or in the 12 hours of light and darkness. That's the response variable, is the growth. So that's what you're going to have in every experiment. You're going to have a treatment and you're going to have a response variable. What are you looking for? What are you doing, and what are you looking for in this experiment? Page 7 says, in an experiment, random assignment of subjects to treatments is done to create comparable treatment groups. All right, I'm going to let you read the rest of that. It says, how might the biologist go about randomly assigning 12 plants from the 24 candidates to receive weed killer A? Could she be sure to get exactly 12 plants assigned to weed killer A and 12 plants to weed killer B by tossing a fair coin for each plant and assigning heads up plants to weed killer A and tails up to weed killer B? If not, suggest a method that you would use. Okay. So, no, that would not be a good example. Okay. But you could do a random number generator. And we're going to see random number tables, which I absolutely cannot stand doing. But we'll look at them now with technology the way it is. You can say, hey Siri, give me a random number. Or plug it into a Excel spreadsheet, and it can generate a number between 1 and 12 or 1 and 24. Okay. So now it says, write or say to your 2 things that are important about experiments, right? So let's talk about what's important when we're talking about experiments. Okay. It says, in experiments, subjects may not have been chosen randomly from a population, but must be randomly assigned to treatments to create comparable treatment groups. Okay. So in the example above, we've got 24 candidates. We're not randomly picking those. We've been given those. Now we need to randomly assign treatments. Okay, whether that is weed killer A or weed killer B. Now we need to randomly assign those. That's what it's saying there. In an observation or in a survey, you need to randomly select the choose the population. But here we're not given that example or that option. Now we have to randomly choose the treatment. Okay. Page 8 says, for each of the following study descriptions, identify whether the study is a survey, observational study, or an experiment, and give the reason for your answer. For observational studies, identify the population of interest. For experiments, identify the treatment and response variables. So A says, a study investigated whether boys are quicker at learning video games than girls. 20 randomly selected boys and 20 randomly selected girls played a video game that they had never played before. The time it took them to reach a certain level of expertise was recorded. Okay. So, in this, it's going to be an observation. Okay. It's going to be an observational study. The children were observed and no treatment was administered to them. The population of interest was all boys and girls who would play the video game that they had never played before. The study was to see who was quicker at achieving a certain level of expertise. So, in the observational study, what is the population of interest? It is those students that would play the game that they had never played before. That's it. And what are you looking for? A quicker achievement of level of expertise. All right, B says, as your statistics project, you collect data by posting 5 questions on poster boards around the classroom and recording how your classmates respond to them. Well, that's going to be a survey, right? You're just asking questions. Questions were asked of classmates. Students may question whether this is really a sample survey since all classmates participated. They were not randomly chosen, but full marks to those who suggest that it is a census, okay? So that's kind of the answer that you may give, and they're saying, good job if you point out that it's not randomly chosen there. It's a specific group, not a random group of students. All right, professional sports team traded its best player. The local television station wanted to find out what the fans thought of the trade. At the beginning of the evening news program, they asked viewers to call one number if they favored the trade and a different number if they were opposed to the trade. At the end of the news program, they announced that 53.7% of callers favored the trade. So this is just another survey. You've asked a question and you've expected a response from it. So this is called a voluntary response. It is a very poor way of gathering data since subjects are clearly not randomly chosen. It's only the viewers of this local television station, and it's just the ones that wanted to respond. So those that are mad about it may call in, or those that are really glad that happened, they call in. So it's not really a fair, it's not a random as it needs to be. D says, the local Department of Transportation is responsible for maintaining lane and edge lines on paved roads. There are 2 new paint products on the market. 20 comparable stretches of road are identified. Paint A is randomly assigned to 10 of the stretches of road and paint B to the other 10. The department finds that paint B lasts longer. Well, you got treatments and you've got responses that you're looking for. So this is an experiment. The stretches of roads that are the subjects in this study are randomly assigned the treatment. They're given to you. You've got 20 of them, but you're randomly assigning the treatment. The response variable is the longevity of the paint, how long it lasts. Students may note that the other factors could affect the experiment, like weather, traffic, or other, other lurking variables. That's a good word. Lurking, something we may not actually notice or see there. Okay. The National Highway Traffic Safety Administration conducts annual studies on driver seatbelt use at a random selection of roadway sites in each state of the United States to determine if seatbelt usage has increased. Okay, data are analyzed over 2 successful years. So 1 year after another. That's just an observational study. No treatment is administered. The population of interest was drivers observed at various randomly selected roadway sites, and the study was to observe seatbelt usage over a 2-year period. Okay, so what you're looking for is the usage over a 2-year period. Your population was randomly selected roadway sites, so those you can't know who's going to be traveling on those roadways at certain times, so it's very random. All right. F, people should brush their teeth at least twice a day for at least 2 or 3 minutes of each brushing. For a statistics class project, you ask a random number of students at your school questions concerning their toothbrush. Well, that's just going to be a survey, right? You're just asking them questions about how they brush their teeth or how many times they brush their teeth. Okay, G says a study determines whether taking aspirin regularly helps to prevent heart attacks. A large group of male physicians of comparable health were randomly assigned equally to taking an aspirin every second day or taking a placebo. After several years, the proportion of the study participants who had suffered heart attacks in each group were compared. So I think this is obviously going to be an experiment because you're giving them either aspirin to take or a placebo. So those are the two treatments. Okay? But the response variable is whether or not they suffered a heart attack. Okay? And I don't like that this is a large group of male physicians. Okay? Those are two things I don't like about it, is that you chose to do male only and you chose physicians. So that really narrows down what you can say as your experiment. You can't say that, oh, the aspirin helped with heart attacks or did not help with heart attacks. You have to say the aspirin helped reduce the chances of a heart attack in male physicians. Okay, you can't just use a broad overview. Okay. All right. The following is the stated conclusion reasonable. A study found that relationship between the happiness of elderly people and the number of pets they have. Therefore, having more pets caused elderly people to be happier. Well, no. Remember, this is an observational study. No treatment was administered to the elderly. Note, consider asking the students to create a scenario as an experiment. For example, 40 elderly people were found who had the same degree of happiness on some happiness scale. 10 of them were randomly assigned to no pets, 10 to 1 pet, and 10 to 2 pets, and 10 to 3 pets. 6 months later, the happiness measure was taken on the people. If, for example, there was an increase in happiness as the number of pets increased, the conclusion that having more pets causes elderly people to become happier would be reasonable. Remember, just in an observation, you cannot use a cause and effect scenario or conclusion. Okay, number 3 says the researcher wanted to find out whether high levels of certain drug given to experimental rats would decrease the time it took them to complete a given maze to find food. Why would the researcher have to carry out an experiment rather than an observational study? Well, because you're having to give them a treatment, right? You've got to give them a drug, okay? To make a cause and effect conclusion requires an experiment to be done. Cause and effect cannot be concluded from an observational study or a survey, which is what that's saying is. To do this cause and effect, you've got to have a treatment. Okay? I think this is the last one. Describe the experiment that the researcher might carry out based on 30 comparable rats and 3 dosage of levels. 0 milligrams, so not giving them the drug, 1 milligram, and 2 milligrams. Right, so how would we do that? Well, the researcher should randomly assign 10 rats to dosage levels of 0 milligrams, the control. That's the, hey, we're not giving anybody anything. This is just a general population of rats. 10 rats, the dosage of level 1 milligram, and 10 rats to the dosage of level 2 milligrams. The researcher should then record the times it takes each rat to complete that given maze to find the food. All right, the lesson summary. 3 types: observational, surveys, and experiments. Observational studies records values of variables for members of a sample. You're just observing, recording those variables, the values of the variables. And a survey is a type of observational study that gathers data by asking people a number of questions. An experiment assigns subjects to treatments for the purpose of seeing what effect the treatments have on the response. So here's what you have to watch out for. To avoid bias in observational studies and surveys, it is important to select subjects randomly. Cause and effect conclusions cannot be made in observational studies or surveys. In an experiment, it is important to assign subjects to treatments randomly in order to make the cause and effect conclusion.